Hello YouTube family, let's solve for the value of x given this nice algebra problem, which is x cubed, this is equal to 125 divided by 8. So what is the value of x? Solution. Now we have x cubed, this is equal to 125 divided by 8, okay? Now from what we have, you find that 125, okay, can be expressed as 5 raised to power 3, and 8 can also be expressed as 2 raised to power 3, okay? We are saying that x cubed, this is equal to 5 cubed divided by 2 cubed, okay? So let's take 5 cubed divided by 2 cubed to the left hand side. We are going to have x cubed subtract 5 cubed divided by 2 cubed. This is equal to 0, okay? Now from what we have here, 5 cubed divided by 2 cubed, this can be expressed as 5 over 2 raised to power 3, okay? This is applying the property that's given a raised to power n given divided by b raised to power n. These are two equations with different bases raised to power n. This is expressed as a over b raised to power n. So we're applying this property. Now from this, we're going to have x cubed subtract 5 over 2 cubed. This is equal to 0, okay? Now as you can see, x cubed subtract 5 over 2 cubed, this is the difference of cubes, expressed as a cubed subtract b cubed, which is equal to a minus b, a squared plus ab plus b squared, okay? Half x cubed minus 5 divided by 2 raised to power 3. Definitely this is the difference of two squares, expressed as a cubed subtract b cubed. This is equal to a minus b, a squared plus ab plus b squared, okay? Now from what we have x cubed subtract 5 over 2 cubed. This can be expressed as, this is x minus 5 over 2, okay? Here we're going to have x squared, okay? This is plus 5 over 2 x plus 5 over 2 squared, okay? Let me just go then write it again here. We're going to have x minus 5 over 2. This is x squared plus, this is 5 over 2 x plus 5 over 2 squared, okay? So this is equal to 0, okay? Now the first value of x, we have x minus 5 over 2, this is equal to 0, and that means that the first value of x is equal to 5 over 2, okay? Which is a real root. Okay? Now inside the bracket we have x squared plus 5 over 2 x plus, this is 5 over 2 squared, which is 25 divided by 4. This is equal to 0, okay? So this is a quadratic equation, okay, that is expressed in the form of ax squared plus bx plus c. This is equal to 0. So from our quadratic equation, a is equal to 1, b is equal to 5 over 2, and c is equal to 25 divided by 4, okay? Let's determine the discriminant value so that we can ascertain the nature of the roots. So the discriminant value is expressed as b squared minus 4ac. Let's check if it is less than 0 from what we have. So b squared, we have 5 over 2 squared, subtract 4 times 1 times c, which is 25, divided by 4. Okay? Now from what we have, this is 5 over 2 squared. From what we have 5 over 2 squared minus 4 times 1 times 25 over 4. And this is equal to 25 divided by 4. Subtract 25 times 4, this is 100, divided by 4. So if you get the LCM here, this is 4 divided by 4, which is 1 times 25, this is 25. Subtract 4 divided by 4, which is 1 times 100, this is 100. So here we have negative 75 divided by 4, which is less than 0. So that means here we have two complex roots. We have two complex roots. So let's solve for this complex root. We can solve this complex root by applying the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, divide everything by 2a. Okay. Now from what we have, negative b, that is negative b, this is negative 5 over 2 plus or minus the square root of b squared minus 4ac, which is the same thing as negative 75 divided by 4, this divided by 2. Okay, so this is equal to, we're going to have negative 5 over 2, remember this is also divided by 2, negative 5 over 2 divided by 2, this is 2 over 1, plus or minus the square root of, from what we have here, we can write this as square root of, this is 75 divided by 4 times negative 1. Okay, and also this one divided by 2, which is 2 over 1. Okay, what we have here, we have negative 5 over 2 divided by 2 plus or minus the square root of b squared minus 4ac, which is negative 75 over 4 divided by 2. All right, now this is the same thing as negative 5 divided by 2. Now this is divided by 2, so here we multiply by 1 over 2 plus or minus. Now from what we have here, negative 75 can be expressed as 25 times 3 times negative 1 divided by 4, then we divide by 2, which we can just say times a half. Alright, now again from what we have, this is negative 5 over 2 times a half, which is negative 5 over 4, plus or minus the square root of 25, this is 5, the square root of negative 1, this is I, square root of 3, divided by square root of 4, this is 2, times a half. Okay, so this is times a half, so that you're going to have negative 5 over 4 plus or minus, we're going to have 5i square root of 3 divided by 4. Okay, so from what we have here, that means that we have two complex roots, that is x2, which is negative 5 over 4 plus 5i square root of 3 divided by 4. Okay, and also x3, which is equal to negative 5 over 4 subtract 5i square root of 3 divided by 4. These are the two complex roots. These are the two complex roots. And that affirms that our equation has got three solutions, with x1 equal to 5 over 2, x2 negative 5 over 4 plus 5i square root of 3 divided by 4, and then x3 negative 5 over 4 subtract 5i square root of 3 divided by 4. All right, so that's the solution to this algebra problem. So thank you for watching and kindly subscribe.